Today we're going to look at LeetCode question number 1, toSum. Given an array of integer nums and an integer target, return the indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, so that makes it easier. And you may not use the same element twice, same meaning the same element at the same position, so you can't use this 2 twice here. If the 2 was somewhere else, then sure. But we can't use this one twice. You can return the answer in any order. So if you look at this example here, 2 plus 7 obviously equals 9, so return indices 0 and 1. That's the positions these values are at. A naive approach would be to go look at each element in the array and then look at all the elements after that, the one that's in focus, and check if they add to the target value. For example, for this first example here, if we look at 2, if the value in focus is 2, we look at every other element after 2, so we have 7. And coincidentally, they actually do equal to 9, so we return indices 0 and 1. But what if we had a super long array with like 100 elements? And our target is 3, and we have 2 and 1 all the way at the very end here, and none of these other elements before the last 2 are 2 or 1. So this is the only answer basically. As the problem states, exactly one solution. So we would have to check each element and all the other elements after that. So we have to check this first element here, and then all the other elements. None of them equal to 3. 3 is our target. So we look at the second element here, look at every other, and we have to, this would be an O of n squared solution because we're iterating through the array twice basically, just to look for this answer. But there's a better way. What if we just remember the element we looked at? How can we remember? We can use a dictionary actually to store the element we just looked at. So, for example, once we do that, we can just scan through this array only once and use that dictionary to check if target minus the value we're looking at, it is in the hash map. If it is, that's great. We return the positions of the value and the target minus value found in hash map here. So basically, if we look at this example, target is 6, and obviously the answer is 2 and 4 back here. So let's have our hash map here, where the key would be the value here, and the value would be the position that the key is in. So if we're like looking at this example, it would be 3 and 0. So let's say we start at 3. This is our target value right now. So we look, is 6 minus 3 in this hash map? No, it is not. So we should move on. But before we move on, we want to store 3 and the position where the value 3 is in the array. Okay, great. We look at 2. Is 6 minus 2 in the array? Is 4 in the array? No, it's not. So what we do is store 2 and 1. Okay, and then finally we'll look at the last element, 4. Is 6 minus 4 in the array? Yes, it is, right here. So we return 1 and 2, the positions, and 4 is at position 2. So that's what we return. We'll store the numbers we just looked at and their positions, and for each element we'll check if a target minus element is in here, is in this dictionary here. So to code this up, I forgot to mention the runtime with the hash map solution or dictionary, whatever you want to call it. It would be O of n, where n is the length of the array, because we're only iterating through the array once. We don't have any nested loops where we iterate over the array twice. So this would be linear time, O of n. So first, what I want to do is initialize my dictionary here. There, that's how it's done in Python. And then for position and value in nums, or enumerate nums, this is this notation here to get the position, the index, I'll just name this index, and the value at the index at the same time. So we want to check if target minus val in hash map, then return return in an array format hash map target minus val, because target minus val would be the key, and the value we want to get is to index value where it's at, and index of this value here. Else, what we want to do is just store in hash map the val equals index. Yeah, and this should always be exactly one solution, so this should always manage to return something. Okay, let's try compiling. Okay, that works, and I'll submit. Okay, thanks for watching.